Hey everyone, welcome to this headfirst dive into the world of model deployment and serving. Most projects never see the light of day because deployment is where things break. So here we are, whether you're just starting out or already knee deep in machine learning systems, this session is designed to be simple, fun, and super helpful. We'll keep things light but insightful, and I promise no jargon overload. So here's our game plan for today. First, we'll explore how models are deployed, kind of sending them into the wild. Then we'll look at how they are served. That's how they actually deliver predictions. And finally, we'll wrap it up with tried and tested true best practices to keep your deployment smooth and reliable. Sounds good? Let's roll. Alright, let's talk about deployment strategies. Basically, how your model gets into the world and starts doing useful things. The first one is one off deployment. It is like a one time gig. You run the model manually for a specific task, maybe a research experiment or a quick analysis. It's great for testing ideas, but not something you'd want to scale. The next up is batch deployment. It is your classic scheduled job. You process data in chunks, maybe every night or every hour. It's perfect for things like churn prediction or fraud detection, where you don't need instant results. The third one is real time deployment, and it is where things get exciting. Your model responds instantly to API calls, powering chatbots, recommendation engines, and personalization systems, but it comes with responsibilities, and to name a few, low latency, high uptime, and solid monitoring. Edge deployment is the last one that I want your attention on today. It is a cool kid off the block. Your model runs directly on the device, phones, sensors, even drones. It's fast, private, and works offline. But it's also tricky. You've got limited compute and memory. So, optimization is the key here. Each strategy has its place. The real magic is in choosing the one that fits best to your case. And now that the model is deployed, let's talk about how it serves predictions. So, first up that I want to discuss is embedded serving. It is the simplest form. Your model is bundled right into your application. It's fast and easy, especially for mobile and desktop apps. But updating it means updating the whole app, not ideal for frequent changes. Then the next one is microservice based serving. It is the gold standard in production. Your model lives in its own service, exposed via an API. It's modular, scalable, and easy to monitor. You can update it independently and scale it based on traffic. Let's talk about multi model serving. It is efficient. One server hosts multiple models, great for platforms with diverse use cases, but it needs smart routing and isolation to avoid mix ups. So that's the catch right there. Next is serverless serving, and it is cloud native and super flexible. You deploy your model as function like on AWS Lambda or Azure Functions. It auto scales, you pay only for what you use, and there's no server management. But be aware of cold starts and latency spikes. And the last one for us today is edge serving. It is where the model lives on the device and serves predictions locally. It is fast, private, and resilient to network issues, perfect for wearables, smart cameras, and autonomous systems. But again, you are working with limited resources. So pick your architecture based on latency needs, scale, cost, and how often you plan to update your model. There's no one size fit all, so that's the fun part. And that brings us to our last part for the day, and that's strategy and best practices. So let's bring it up all together. First, match your strategy to your use case. Don't force a real time setup for a batch problem, and don't try to run a giant model on a tiny edge device. Understand the business need, latency expectations, and operational constraints. Second, the performance, cost, and scalability. Measure latency, throughput, and resource usage. Estimate cloud costs, stress test your system. These numbers will guide your decisions and help you avoid surprises. Now, here are some best practices that I swear by. First up is like I always start with automate deployments. Manual steps are error prone and slow. Use CI/CD pipelines to push models safely and consistently. Then monitor regularly is important. Track prediction latency, error rates, and data drifts. If something goes wrong, you want to catch it early, not after users do. Then we should use version control where we track model versions, training data, and configs. This helps with rollback reproducibility that's essential for audits, and it's like having a time machine for your models. Then scale resources smartly. That's about using auto scaling, load balancing, and caching. Don't over provision, but don't under provision either. Find that sweet spot. And next is like do want to try the A/B testing for validation, where you deploy new models to a small group first, compare performance before going full scale. It's safer, smarter, and builds confidence. And last up is that I really recommend and follow by is maintaining documentation and logs. Document your deployment process, model assumptions, and serving endpoints. Logs help with debugging, compliance, and learning from mistakes. These practices aren't just technical, they are cultural. They build trust, reliability, and speed in your ML workflows, and they make your life easier too. Now that we've got a clear picture of what model deployment and serving really means, let's decide where we head next. Should we take the next step and containerize a model with Docker? Should we dive deeper and deploy it on the cloud with full infrastructure support? Should we take a step back to understand how to engineer and prepare data for ML? Or would it help to go all the way to the beginning and build the foundations of machine learning itself? Let me know in the comments. I read everyone. Your vote shapes the journey we take. Thanks a bunch for watching this video.